basic operations with functions. And specifically talking about if I have f of x, g of x, h of x, how we can combine them, add them, subtract them, divide them, change one into the input of the other one. That's what we're talking about today. We're going to start with just sum, difference, product, and quotient. For sum, we're not just going to say 2x minus 3 plus x squared minus 1. Instead, we're going to use notation like this. We're going to use something that looks like f plus g of x. But really what that means is just take f of x and then add g of x. It's just a slight shortcut, so I can just write x once because we're using the same input. So I can just say it's f plus g. Remember, these are just names. It's just like Ahmed plus Joey input x. All right, these are just names. Function f plus function g both have the input of x. So in our example up there, we're just going to do fx plus g of x. All right, so in that example up there, if I give you something like this, f of g of x, you are just going to take f, which is just 2x minus 3, and you are going to add g to it, which is x squared minus 1. Now you'll note I'm going to use parentheses for them. Parentheses aren't key when we're adding, because when I distribute the addition sign, nothing happens. I just like to keep doing that because I think we've all been to a place where there's a negative out front and we forget to distribute it. And then we get it wrong, and then we have to ask why it's wrong. So I just continue to use parentheses, whether I'm adding, multiplying, dividing, or whatnot. All right, so we just have to add those two things together. Well, that x squared has nothing to go with, so I'm going to bring that out front. 2x is just going to be plus 2x. Finally, we have a negative 3, a negative 1, so it's negative 4. So x squared plus 2x minus 4 is f plus g of x. Difference. Ooh, it's going to blow your mind. Based upon the first one, this is way different. We do f minus g of x. Whew. That is just saying take f of x and subtract g of x from it. It's important to know what order to do it in. Right? 4 minus 2 is way different than 2 minus 4. So from the example above, if I was asked to do f minus g of x, is just saying take f, 2x minus 3, and subtract g away from that, which is x squared minus 1. Now, thanks to my parentheses, I'm going to realize that I need to distribute that negative sign. So in fact, I really have a negative x squared and a positive 1. So when simplified, I'm actually going to have a negative x squared. I still have a positive 2x. I have a negative 3, a positive 1, which is going to be a negative 2. We got both those down? I think I did another slide for product and quotient. I want to take a guess at how I'm going to write the product one. Yeah.
Would it be f and then it's like a circle? Like
nope, you're looking up. You're thinking of f of g. We'll get to that on the other side.
So it's just multiplication, like f
yeah.
times g.
Of x. Yeah, yeah. Our product is just going to be f times g of x. But that's just saying take f of x and multiply g of x. Unfortunately, I do not have my fx up there anymore. That's the one problem going to this thing. So let's go ahead and do f times g of that old x is going to be f, which is going to be 2x minus 3, times our g of x, which is x squared minus 1. All right, as you know, I don't use FOIL or anything. What I actually do in my head is I just do 2x times x squared, and then I do 2x times negative 1. Well, 2x times x squared is 2x squared. 2x times negative 1 is minus 2x. Then what I do is I move on to the next, that negative 3. I do negative 3 times x squared. Yeah.
Wouldn't it be 2x to the cube, like 2x cubed?
Oh, yeah, it should be 2x cubed. You are 100% correct. Good catch. Otherwise, we would have been all the way at the bottom, and I'd have been like, that doesn't look right. 2x is correct, though. I got half it right. That's 50%. But then we do negative 3 times x squared, which is negative 3x squared. And finally, we do negative 3 times negative 1, which is going to be a positive 3. All right, reorganize that stuff. We'll have 2x cubed minus 3x squared minus 2x plus trace. We're done. Quotient, pretty much just like product. We do have to put a little addendum onto it. A little bit extra, and I'm not sure if I have room to write it. It's kind of zoomed in a little bit. Let's see if I can make it a little small. So that would just be f divided by g of x, which is just going to be f of x divided by g of x, but we have to put a caveat onto this. Can anyone guess what we need to add to this? Yeah.
G of x cannot equal 0.
Perfect. G of x cannot equal 0 because that would be undefined. All right, let's go ahead and do that. I'm going to put a little wall up because I kind of went a little too far on this, and then I get angry at stuff overlapping. All right, so we're going to do f over g of x. Well, that's just going to be our f, which is 2x minus 3 over x squared minus 1. And there's no real way to simplify that, except it's not done. If I would do this on a test, I would lose a point. And it has to do with this. Yeah?
So then would you just like write a comma? And then
Yeah, we can write a comma.
and then be like, oh, it's not equal to.
Well, you're not going to put the whole thing. You're going to say x can't be certain numbers or a certain number. What number makes this 0? That's what you're going to ask yourself. What number makes this 0? Joey. 1 and negative 1. So I'm going to say x can't be positive or negative 1. Don't forget. Don't lose 1 point and be like, oh, I knew that. Right? Isn't that the worst when you get a test back and you're like, oh, I knew that. So that is adding, subtracting, multiplying, and dividing when we have two functions and the notation for it. All right, sliding down. We're going to talk about domains. Domains. So when I add two functions together, I subtract two functions, I divide two functions, or I multiply two functions. Sometimes our domain changes. Well, our domain when we add, subtract, divide is going to be all real numbers that are common to the domain of both functions. So if you have one function going from negative infinity to infinity and one going from 0 to infinity, the overlap is 0 to infinity. All right, it is what they both have in common. So let's look at this. This says if f of x equals square root of x and g of x equals square root of 4 minus x squared. What I'm going to do real quick, because we need both of these domains, I'm going to think about what's the domain of each one. So let's do the domain of, let's do square root of x. Who can tell me what values I can plug into square root of x and get real numbers out? What are all those numbers I can plug into it?
I'm sorry.
Oh, what is the domain of square root of x? Yeah,
1 to infinity.
close. You're missing one that works. 0 to infinity, perfect. Because the only thing that doesn't work is negative numbers, right? So the domain is going to be 0 with bracket all the way to infinity. All right, let's also mark down the domain of square root of 4 minus x squared. This one's a little trickier. What is the domain of 4 minus x squared? You got it?
I think so.
Awesome.
0 to 2 and 2 to infinity.
2 to infinity?
Sorry, no, not 2 to infinity, my bad.
2 is right.
2.
So we got 0 to 2.
That's it.
That's it. There's a little bit more.
Oh.
Yeah, no, you keep going.
Negative 2 to 2.
Negative 2 to 2. Perfect. No, you got it. This is going to be negative 2 to 2. Negative 2 works. Hey, this is a half circle. You have to start recognizing this is a half circle. A half circle goes from one stage to another. And if I plug in negative 2, that works. 2 works. Anything bigger than 2, so 4 minus 3 squared is 4 minus 9. No. 4 minus negative 3 squared is 4 minus 9 again. No. It's just from negative 2 to 2. All right, we're supposed to find f divided by g of x, and I need to find the domain. So how did I set that up? I did f divided by g of x is just going to equal my f function, which is square root of x, divided by my g function, which is square root of 4 minus x squared. Something like this. Are we allowed to have square roots on the bottom of a fraction? I'm going to be okay with it here. All right, it's a big ask to get rid of it, and I'm more concerned about, can you write this? And then can you find the domain of it? So we're going to leave the square root in it because the square root can help us find the domain a little better. So in these types of equations, just because it's a big square root, it gets really hard to start moving it to the top and dealing with square roots. I'm going to say it's okay in these problems. Okay, we're just going to leave it as that square root of 4 minus x squared. All right, let's get the domain. Let's get that domain. So to help me do that, and if you don't need this, awesome. I'm just going to do a quick number line and show where they overlap. So square root of x, let's just do this at 0. We'll make this negative 2. We'll make this 2. Well, the domain of square root of x looks something like this. You'd have a closed dot at 0, and it goes all the way to infinity. G of x, maybe I should have put there. Our g of x, or our square root of 4 minus x squared. And I'm going to draw it first. I just ran out of room here. So this domain right here, from negative 2 to 2, is going to be our square root of 4 minus x squared. Now remember, the domain is the overlap. So this right here is our overlap. So currently it looks like it's from 0 to 2. So based upon this, our domain would be, now don't write this down just yet because something's off on it, 0 to 2. There's something off about this. Overlap is correct. These brackets are right for that overlap, but what's off about it, Lily? It can equal 0. Yep, because 0's in this domain. 0's in this domain. The only problem you'd run into is, if I plug 0 in here, do I get a 0 on the bottom? 4 minus 0, square root of 4. It works. So 0 works. You're on the right track, though. Joe.
Excluding positive 2 instead of including.
Excluding positive 2. Based upon this drawing, 2's allowed. But you have to go back to the new equation you set up. Can I plug 2 into this? Because that'd be 4 minus 2 squared, which would be 4 minus 4, which is 0. I can't have 0. That 2 needs to turn into a parenthesis 2. And I think I put a little note to myself because 2 would give a 0 in the domain. or in the denominator. But that's all we needed. I gave the equation up here. Like I said, we don't need to simplify that. And our domain is 0 to 2, including 0, but not 2. Lily, does that make sense why 0 does work?
Yeah.
Yep. It's good thinking, though, because it always has to do with brackets and parentheses, right? All right, the last one is find g over x. And you're supposed to find the domain. So g is now square root of, so our g divided by f, oof, that's a weird f. F of x is going to now put my g of x on top, which is our square root of 4 minus x squared. And it'll be all over our f of x, which is square root of x. Does someone want to jump out on a ledge and tell me what they think that domain is?
Promoting dangerous behavior.
In the classroom, yes. Risky behavior of taking guesses. Because there's a chance you could be wrong. Amanda. Perfect. It is parentheses 0. Remember, this overlap says it could be. This overlap with that red says it could be bracket 0 to bracket 2. You just have to look at the new equation that's formed to determine if anything else is lost. Well, we can't plug 0 in because square root of 0 is 0, but 2 suddenly works again. 2 works, so that's why it's going to be parentheses 0, bracket 2. I think, honestly, with domain, these are the hardest ones because not only do you have to worry about the overlap, you also then have to go, okay, this is my possible domain. Now, what am I going to lose because I can't have zeros in the denominator? All right. Most of the time, you can just go, okay, my overlap, that's my domain, because most of the time it's not a fraction. Usually it's multiplying, adding, or subtracting. All right, continuing on. This is what was brought up earlier. A composite function. A composition of functions is basically I'm taking one function and plugging it in as the input of another function. And that's called a composite function. And it'll look something like this. It looks like fog and goth. But what's actually happening there is it's actually saying f of g of x. So that's what we're saying here. F of g of x. F of g of x. So that means we're doing f of g of x. We'll first find g of x, and then we'll plug it in for f. Just like down here, our goth is g of f of x. So this one is my g of f of x. So we always work inside out. What I mean by that is we always start with the x, plug it into the g, find that value, plug it into the f. And we'll have ones that are stretched out. You'll see there's like an f of g of h. Just keep working. If I give you 50 of these, it would just be x of the first letter, then plug it in the next one, plug in the next one, plug in the next one. So we're working from inside backwards. All right, so if we have f of x equals x plus 2, and we have g of x equals 4 minus x squared, if I'm doing f of g of x, remember, I can write that as just f of g of x. If I expand that, I'm actually saying take f of, and g of x is actually 4 minus x squared. I am now taking that entire 4 minus x squared and plugging it in for every x that appears in f of x. So this is my new input. So we're going to rewrite that as, instead of the f, I'm going to take that whole thing and plug it in for those x's. So we are going to have 4 minus x squared plus 2. So like I said, we take that 4 minus x squared and actually plug it in for that x. That's what happened there. Then we just simplify. Well, that's just move that x squared out front, so that's negative x squared. 4 plus 2 is 6. That is f of g of x. That is g of x being inserted into f of x. And this happens with a lot of real-world equations, because you want to calculate something and then you want to put that equation into another equation. Here, we have g of negative 2. G of f of negative 2. So once again, what I'm looking at is I'm doing g of f of negative 2. Well, that's just going to equal g of, we'll plug that negative 2 in for x of our f of x. So that's going to be negative 2 plus 2. Well, that's just g of 0. Yeah.
Wait, never mind. I just figured out.
Okay.
The negative 2, I was going to ask, where does that come from?
Oh, you got it? Yeah.
Can I go to the bathroom?
Sure. Another way to do these also, let me just, sometimes it's easier for people just to do, people will honestly find your f of negative 2 off to the side and then plug it into their g of x. I'm just showing you what happens as breaking. And you'll see in my answer guide, a lot of times I just find my f of negative 2 and then I plug it in for g. But this is what's happened. Now we have g of 0. Now we plug that 0 in for our g. Our g is 4 minus x squared, so we're going to have 4 minus 0 squared, which is just going to equal 4. Are we all okay with the notation? Because the notation can be the thing that bogs us down. Like I said, in the homework, more than likely you'll probably just do f of negative 2, find out that value, plug it in for your g value. Okay, just make sure you do things in proper order. All right, that third example, we are supposed to do f of g of x, and we're supposed to find that domain. All right, so we're doing f of g of x. So let's first find our domains. Let's find our domains. Let's start with our domains. So our domain of f. Can someone tell me the domain of f? What values can I plug into there and still get real numbers out? Ahmed? Yeah, negative infinity to positive. Negative infinity to positive infinity. All right, let's go ahead and find the domain of g. G, I want to know what that domain is. Anna, do you think you know the domain of g? Negative 3 to 3. Perfect. It's one of those circle ones that we keep doing over and over and over. Negative 3 works, 3 works, 0 works, 4 doesn't work, negative 4 does not work. Are we dividing? Do we have to worry about the division being 0, though? No, so we just have to list the overlap. So because we are multiplying, we can actually find our f of g right off the bat. And that is just where it overlaps. So our domain of f of g of x is going to be where they overlap. Well, the first one's negative infinity to infinity. So where they overlap must just be the domain of g. So it's going to be negative 3 to 3. Recall, that is the overlap. That is our overlap. And I don't have to worry about adjusting because we're not doing a fraction. All right, let's actually do our f of g of x now. Maybe I'll do a little divider. So our f of g of x is actually f of g of x, which is going to equal. So the way I do it sometimes without writing it all is I just look at g of x, and I take all that and plug it in there. So this is going to be square root of 9 minus x squared minus 9. I guess we do the square, so we can simplify that a little bit, which is going to equal 9 minus x squared minus 9, which is going to equal negative x squared. Here's why I did the domain first. If you do the domain now, you're going to fall in the trap of saying it's negative infinity to infinity, because it's just negative x squared, it looks like it. I promise you, if you graph this in your calculator, which you can do later on, or now if you have it out, if you graph this in your calculator and you zoom out, you're going to see it's an upside down parabola. It looks like this, but only goes from negative 3 to 3 and just stops. So it actually, your calculator won't even graph at all as long as you plug this in. It'll be an upside down parabola, just like this looks like, but it'll only go from negative 3 to 3 and it'll just stop. It'll be part of that. And that is because you only can plug negative 3 to 3 into this. So you get your domain first and then get your function. Don't let your function sway your domain. All right, that domain is still negative 3 to 3. All right, the last thing we have to cover, and what time is it? We're running behind. No, we're okay. The last thing we have to do is go backwards. We're going to write h of x as a composition of two functions, f of x and g of x. It says look for an inner function that could be plugged into an outer function. All right, so what I usually do is I look for, you see that x plus 2? I'm going to say that's my inner function. I'm going to say that's my inner function. So I'm going to let g of x equal x plus 2. That is my inner function that I came up with. Because we kind of picture, I'm just going to insert that x plus 2 somewhere. Which means my outer function, let's go ahead and call it f of x, is going to be 1 divided by x squared. That is going to be my outer function. I want you to picture this. If I took this x plus 2, plugged it in for that x, I would now have x plus 2 squared in the denominator, right? So if I just take this and plug it in there. So the composite that does these two functions is going to be f, and we're going to plug g of x into f, which is going to be written as f of g of x. Let me try the next one. Go ahead and do the next one. This one had another possibility too. I could have did x plus 2 squared and just made this 1 over x. That would work too. There's most of the time there's multiple different ways to solve it. So just try the next one. Okay. How do we do the other one?
Like,
Do you agree that if I took this and plugged it into the x, I'd get that back out?
yeah.
We're doing the same thing.
Yeah. But like, I just don't know, like, okay, like, I don't know how to, like, pick it apart.
Squares or anything.
Yeah.
I just thought g of x
It's like-
was
Pick an inner function.
part of the equation.
What occurs there that's inside of it?
And then
Like
f of
this.
x would just be x.
Right there.
Yeah,
A minus x.
essentially.
Yeah.
Still makes one of your equations 8 minus
And
x.
then
It'd just be X.
Like,
over
you
5.
could, okay.
Yeah,
That's what I thought.
G of x.
Right.
Yeah, that's what I thought.
Should we go for this one?
Just
Put
because
this
it's
one.
Okay, that's one way to do it, yeah. Mm-hmm. Now let's do our f of x.
Because like for this one, that did not.
Would be one if it,
You know what I mean?
then,
But there's nowhere for me to plug this in. I need a variable to show where it's going to get plugged into. So here I put an x squared, so I was going to plug this in there. This shows where it's getting plugged into. Where do you want this plugged into?
the numerator.
The numerator. So what should the numerator be?
X.
X. X marks the spot. That's where I want to plug it in.
Okay.
There you go.
That's it.
That's it. Now you just
So then I would do like G, X, and then
g of x, right? And look, that's what you're supposed to do. All right, I'm going to show both ways to do this one. Well, there's actually more than 2 ways, but these are the most common ways. So what we could do is I'm going to make g of x my inner function. I know to make g of x my inner function because it's the inner part right here. It's actually specifying that it has to be f of g of x. So g of x has to be my inner function. I'm going to make g of x, and don't erase anything. Just add this if you didn't have it as another way. I did cube root of 8 minus x. And then I made f of x equal to x over 5. If I take this and plug it in there, do I get that original thing back out? Yeah, that's one method. The other way you can do it is we can say g of x equals maybe just that 8 minus x. And then maybe my f of x is going to be cube root of x over 5. Once again, if I take this, plug it in for that x, I'm going to once again have cube root of 8 minus x. On the test, both these are acceptable answers. No one loses points because they picked one way versus the other way. All right, these are just 2 perfectly valid ways to do it. All right, the rest of the time is yours.